everyone, welcome to the pre-lecture for Chapter 21. I'm Carly Laska.
And I'm Rachel Simmons, and we're going to talk about the two-sample z-test today. In the two-sample z-test, we are testing hypotheses that compare the averages or percentages of two separate populations instead of one. And it's important to remember that you can only use this if the populations are independent of one another.
So to illustrate the two-sample z-test, we came up with this question: do you believe in ghosts? And actually, last year on Halloween, we found data where they took two samples of 600 men and 600 women and asked them this question: yes or no, do you believe in ghosts? We saw that 38% of the men said yes, compared to 40% of the women that said yes. And we want to know, is this difference between 38 and 40% significant? Is that enough to say that women actually believe in ghosts more? Okay, so just like when we're doing any type of hypothesis test, as you guys know from the one-sample z-test and the t-test, our first step is to always state both our null and alternative hypothesis. So let's go ahead and do that. Rachel, what is our null?
Well, the null hypothesis is dull, so I would say that there's no difference between men and women as to whether or not they believe in ghosts.
That is exactly right.
Okay, so now we have our null hypothesis, but we still need the alternative hypothesis. Carly, what do you think that is?
Well, the null, like we said, is dull and boring, and the alternative is what we're trying to test. So just looking at this data, I want to know, is this 2-point difference significant? And so I want to test, it looks like women believe in ghosts. Women have a higher percentage for believing in ghosts than men, so that's going to be my alternative. Okay, so our next step is, now we want to find a way to compare this difference. And we do that by finding our z-statistic. Remember, since we're doing the two-sample z-test. And this time, because we have two samples and two populations, our z-statistic is a little different. It's not observed value minus expected value divided by the standard error. Instead, it's the observed difference minus the expected difference divided by something called the standard error of the difference. Okay, so for our z-statistic, we need to find the standard error for the difference. And this is just kind of a way to combine the two different standard errors that we have. We're going to have one for men, we have a percentage and an n for men. We can easily find the standard error, the percent. You guys already know how to do that. And we can do the exact same thing for women. So you're going to get two different standard errors. You're going to square each of them, add them together, and take the square root. So this is the formula. You guys are going to learn exactly why this formula works in class, but for now we're just going to give you an example of how to plug in numbers into this formula.
Okay, so since we already know how to do the SE percent, we can just take our numbers, which in this case is 1.98, and we take the square root of that first number and square it, and then we add it to our second value, which in this case is 2, and you square that. And then it's really easy because you can just plug it into your calculator.
Okay, so we found that the SE difference was 2.8 from that formula. So now we need to get our z-statistic. And what I'm going to do is take my observed difference. So that's what I saw in my data. We have an observed difference of 2, right? My two percentages are 38 and 40. My observed difference is 2. If you want to put -2, that is fine as well. You're going to get the exact same p-value, so it doesn't actually matter if you do the positive or negative. I just like positive, so I'm going to keep it as 2. Minus our expected difference, and that's what we'd expect under the null hypothesis. So looking at our null hypothesis, it says that there's no difference in percentages. This is actually always going to be 0. Always, no matter what problem you're doing with the two-sample z-test, our expected difference is always 0 in stat 100. So I have 2 minus 0 divided by 2.8. Okay, so my z-statistic is 0.7, and now what I want to do is find the p-value. So we're doing a z-test, which means we're using the normal curve. 0.7 is going to be right about here. And remember, my p-value is the probability that I'm going to see the difference that I saw, or something more extreme, or something bigger, if the null hypothesis is true, if there's actually no difference between men and women in the percentages if they believe in ghosts. So what I'm going to do, I want this right-hand tail. So Rachel, you have a normal table right there. If you look up 0.7, that's going to give you the area in between 0.7 and negative 0.7. So what is that?
It's about 51.6, so I would say 52%.
52, that's a good idea, to round to the nearest whole number. So this is 52. Now how am I going to get this tail? I want that as my p-value. What am I going to do?
I would take 100 minus 52 and then divide that by 2 to get the tail.
That is exactly right. And that is going to give us our p-value.
So it looks like we got a pretty high number here of 24%. And we want to know if we should reject the null or not. So, Carly, how would we decide how to do that?
Well, we have the rule. I told you guys, in this class I'm going to say that if p is less than 5, you do reject the null. P is not less than 5 here, so I guess what that means is that we do not reject our null. We're not going to accept it, but we're going to say that there is evidence of the null, that there's no difference in percentages of men and women that believe in ghosts. So again, what that's saying is these two numbers, the difference between 38 and 40 is not statistically significant for this sample. So we can conclude that there is evidence of our null, there is evidence that in the population there's no difference in percentages of men and women that believe in ghosts. Thanks for watching, guys!
Stick around if you want to watch some bloopers.
Hello everyone, and welcome to the pre-lecture for Chapter 21. I'm Carly Laska.
And I'm Rachel Simmons. And we're going to talk about Chapter 21.
Alright, so as you guys know from doing both the one sample z-test and the t-test, our first step when doing
I totally messed up. I looked at you funny because you moved the kid.
Okay. Stop. You're making me laugh. And now I want to actually get my z-statistic. So 2 minus 0 is 5 divided by 2.8.
Carly, you need to check yourself before you wreck yourself because 2 minus 0 is 5.
Oh, no, you're right. You guys need to remember.
Check yourself before you wreck yourself. I just wrecked myself.
Okay, so I just checked myself and got a z-score of 0.7. So my last step in this process is to figure out our p-value. We want to know, is this 0.7, is this statistically significant? Okay, so thanks to Rachel, I just checked myself before I wrecked myself and got a z-score of a z-statistic of 0.07.
There's
and
no.
now,
You're supposed to say thanks for watching.
Oh, sorry. Okay. Okay, I'm ready. I'll say thanks for watching.
And then I'll say stick around for some bloopers.
Okay. Are we still going? Okay. Thanks for watching. Oh.